Welcome back. Today we are diving into two of Python's most essential data structures, lists and tuples. Now, these are your go-to tools for organizing multiple values inside a single variable, which is going to make your code way more powerful and efficient. So let's just kick things off with a practical problem. Let's say you're a teacher and you need to store the test scores for a whole class of, say, 100 students. How would you even begin to handle that in your code? I mean, you could create 100 different variables, marks 1, marks 2, marks 3, but you can probably imagine what an absolute nightmare that would be to manage. Well, this is exactly where Python's collection types come to the rescue, and we're starting with the most common one. We're going to begin with the most flexible collection type there is, the list. And if you're coming from other languages like C++ or Java, you can basically think of lists as Python's superpowered version of arrays. So a list is really just an ordered collection of values, all packed neatly into one variable. You make one with square brackets, and you just separate each item with a comma. So instead of 100 variables, you get one clean line. Marks equals 94.4, 95.2, 66.4. Much better, right? Lists are just incredibly versatile. You can grab any element you want using its index, and remember that always starts at 0. You can get the total number of items with the len function. And get this, unlike arrays in a lot of other languages, a single Python list can hold different data types all mixed together, strings, numbers, whatever you want. Plus, just like with strings, you can slice them up to get a smaller piece of the list, and you can even use negative numbers to count from the end. Now this right here highlights the single most important thing you need to know about lists. They are mutable. And mutable is really just a fancy word for changeable. So while you can't change a single character in a string after you've made it, that's what we call immutable, you can absolutely change an element inside a list. This flexibility is the real superpower of lists. And because lists are so changeable, Python gives us this awesome toolkit of built-in methods. They're like special functions just for lists that let us add, remove, and reorganize things on the fly. Let's take a look at some of the most useful ones. Need to add items? You've got options. The append method is your go-to for just tacking one single item onto the very end of the list. If you need a bit more precision, insert lets you drop a new element at any specific spot. And if you want to merge a whole other list into your current one, extend will add all of its items to the end for you. Now, when it comes to sorting, Python has two different ways to do it. And this is a big one that trips up beginners. So here's the deal. The .sort method actually changes the original list. It sorts it in place and doesn't give you anything back. But the sorted function, it leaves your original list completely alone and just hands you back a brand new sorted copy. Using the .sort method is super simple. By default, it's going to sort everything in ascending order, smallest to largest. But if you want the opposite, you just pass in this little argument, reverse equals true, and boom, it'll sort your list in descending order. And for taking things out, you've also got choices depending on what you need to do. The del keyword gets rid of an item at a specific index. The remove method will search for the first item that matches a certain value and delete that one. And then there's .pop, which is really cool. It removes an item by its index, but it also returns that item to you, which can be super, super useful. Okay, so we've got a handle on the flexible, changeable list. Now it's time to meet its close relative, the tuple. It looks and acts a lot like a list, but it has one critical, game-changing difference. Tuples are made with parentheses instead of square brackets, but here's the main thing. They are immutable. That means once you create a tuple, its contents are locked in. You cannot add, you cannot remove, and you cannot change any of the elements inside it, ever. So this brings us to a classic Python puzzle, a little gotcha that catches a lot of new developers. If you write tup equals 5, have you actually created a tuple that contains the number 5? What do you think? The answer is no. Without a comma, Python just sees the parentheses as being for math and thinks you're just defining a plain old integer. To create a tuple with just one item, you have to add a trailing comma. That little comma is what tells Python, hey, I'm a tuple. Okay, so you might be wondering, if a tuple is just a list that you can't change, why would you ever use one? It kind of seems less useful at first, but there are actually some very powerful reasons to choose a tuple. Let's break it down. The main trade-off really comes down to flexibility versus performance. Lists are for collections you expect to change. Tuples, on the other hand, because they're immutable, are faster and more memory efficient.
Think about it. Since Python knows a tuple will never ever change size, it can set aside just the right amount of memory for it, making it faster to access. This makes tuples perfect for protecting data that you never want to be accidentally altered.
And this right here just drives the point home. For the exact same data, the list version uses up way more memory than the tuple. See, Python has to allocate all this extra space for the list just in case you decide to add more things to it later. A tuple doesn't need any of that overhead. But maybe the most important technical advantage is this. Because tuples can't change, they are hashable. Now that's a bit of a technical term, but what it means for us is that they can be used as keys in a Python dictionary. Lists, because they can change, cannot. And trust me, that is a critical feature you'll need for more advanced programming. So the next time you're writing your code, you've got to ask yourself, do I need the dynamic, flexible power of a list, or do I need the speed, efficiency, and rock-solid data integrity of an unchangeable tuple? Understanding this choice is a huge step towards writing cleaner, faster, and more reliable Python code. Keep building with it, and we'll see you in the next chapter.